So here we have four gentlemen. Meg Huyal, who is Meg Huyal? Meg Huyal, and then Nizam Sakota, Mukeshwar Kumar Yadav, and Naveen Kumar Shah. They are here to present their project regarding the EDC's exam. So you can start. Well, for just wait. First, we have here Jitendra Kumar, Honorable Jitendra Kumar Mananda sir, to witness their presentation. So, who is shooting?
Manish Adhikari.
Manish Adhikari is on camera, and here we have a friend
Manish Kard.
to help in their presentation. So you can start now.
Good morning everyone, respected teachers, my dear friends present over here. With me Mizal Sakota, electrical second year student, we are here to give a short presentation on the topic solar tracking system using Arduino. We are 4 members here, let them introduce themselves.
Hello everyone, my name is Vivek, 2079 BL second year first part.
Namaste everyone, myself Naveen Kumar Shah, electrical second year first part.
Hello, namaste everyone. Myself Mukeshwar Kumar Yadav from 079 BL second year.
Okay, let's go on to the topic solar tracking systems using Arduino.
We have some audience over here. So they are from electrical group, isn't it? So they are having patience and listening to the presentation. Okay, go ahead.
Let's go on to the topic solar tracking systems. So as we explored the fascinating role of solar tracking system, as solar energy increases, it uses the mechanical or electronic devices. The solar tracking system uses mechanical or electronic devices that orients the solar panels, which can receive the maximum amount of solar radiations coming from the sun, which can rotate according to the sun positions, by which we can increase the efficiency of the solar panels by 40 to 45% comparing to the fixed panels. So this is the importance of solar tracking. By keeping the solar panels aligned with the sun, we can track the radiations coming from the sun, so that as unlike the fixed panels that stay on the fixed positions, they receive only the few amounts of solar, receive only few amounts of the radiations coming from the sun. But when we keep the solar tracking systems, they rotate according to the positions of the sun, they track the path of the sun, so we can receive the more amount of the radiations. So it is the transition of the renewable energy sources. By keeping solar tracking systems, we can reliance on the fossil fuel, we can create environmental friendly environment. So there are 3 types of solar tracking systems. One is single axis tracking, another one is dual axis tracking, the third one is a hybrid axis tracking. So name itself says single axis tracking. It means that the solar panels rotate in a single axis, that is in the north to south directions, or in the direction of sun, that is east to west directions. And the dual axis tracking means that it can tilt and rotate the panels in the perpendicular direction of both the axes. And I will show you one video on the dual axis tracking, which will make them more clear on this topic.
Okay, no problem. We can go ahead. Okay.
And the third one is hybrid axis tracking, which is the combinations of the both single axis tracking and the dual axis tracking. So it is cost effectiveness also. For the next topic, components of solar tracking, I would like to call my mate friend.
My part is to explain the key component that has been used in our project. So we have used solar panels and tracking mechanism as motor, gear, actuators, sensor and controllers like LDRs, encoders and microcontrollers. And we have used Arduino with the Arduino code. So let me first start with the Arduino. Arduino is a controlled development board which is used to read the input signal and control the output signal. We have different pin configuration for different purposes. So we can use the analog pin for the readings, continuous analog signals, and we can use the digital pin for reading the discrete signals. We can also use the external power supplies and internal regulated voltage supplies. The Arduino, in the middle of Arduino, we have the microcontroller chip, which is which is connected to every pin of the Arduino, and which acts as the brain of the Arduino. Let me move to the servo motor. The servo motor is an actuator which controls the velocity, position or acceleration of anything. The servo motor has this position sensor inside it, which continuously reads the shaft's position and sends signal to the Arduino for processing. Solar. We have used solar panel. The solar panel is an voltaic cell which is used for storing the solar's energy and converting it to the DC energy. It uses the voltaic effect for generating the solar energy into the DC energy, and inside it has the silicon solar cell which stores this sun's energy. And we have used the DC power supply as a battery. We have used the jumper wire for the connection. We know the jumper wire is used for electronic purposes, mostly in DIY projects and robotics. We have used the LDR, which is one of the most crucial component of our project, which senses the intensity of light and fluctuates its resistance according to the intensity of the light. If we have brighter light, we have lesser resistance, and if we have dim light, we have more resistance. In our project, the LDR is used for rotating the panel of solar panel according to the sun's intensity. So for further explanation, I would like to call my friend Naveen.
Namaste everyone. Thank you. Myself Naveen Kumar Sai, electrical second year first part. Today in this presentation, I will explain the working mechanism. LDR detects the sunlight and conveys the message to the control system, that is the Arduino, and Arduino controls the motor according to the precise alignment. And to further elaborate, I would like to explain it through circuit diagram. Here is the Arduino, and the servo motor is connected to the pin number 11, and the power supply is through the red wire and black wire. And from we have used two Arduino, and both Arduino are one terminal is connected to the analog signal A0 and A1, and another terminal is grounded to the resistor, and accordingly solar rotate according to the intensity of light falls on the LDR. Next, how the solar tracking mechanism works? Comparison to the fixed tracking. Here the graph shows the intensity efficiency that is obtained with tracking compared to fixed position solar tracking system. Here in efficiency has been increased with respect to time in comparison to static tracking system. Similarly, for mobile static tracking system, the efficiency has been decreased as compared to the tracker solar. Next, I would like to explain the code. Here LDR1 and LDR2 are defined in the analog pin A0 A1, and we have defined a variable error equal to 20 and initial point equal to 90 degrees. And then to connect the servo, we have used servo library file and the void setup, and servo motor is connected to the pin number 11, which is on the servo.attach 11. Servo.write we have used 90 degree, and delay we have used 1000 millisecond, that is 1 second. And for the rotation we have used the loop. In LDR1 equal to analog read the analog signal of LDR. For again next LDR2 read the analog 2 signal, and we have calculated their absolute value among difference. If value is less than equal to error, or LDR value 2 is less than equal to error, loop itself close. If LDR1 value is greater than LDR value 2, then the S point decrease, that is the servo motor rotates anti-clockwise. And similarly, if LDR1 value is less than LDR1 value 2, then the servo motor rotates clockwise. And in this way the project code demonstrated. Next, what are the benefits of the solar tracking system? It has increased the energy output, cost efficient, and reduced the emission. And next, the environmental impact of solar tracking system. Main advantage of the solar tracking system is to reduce the carbon emission, as the carbon is the major component to produce carbon monoxide gas, which is poisonous gas, and promotion to the clean energy, conservation of the resources, and biodiversity preservation. to explain the application part, I would like to call my friend Mukesh.
Thank you, Naveen. Myself, Mukesh Sopanayadam. Microsoft application of solar tracking system. Now these applications are residential solar tracking system. Now next is commercial and industrial solar tracking system. Next is remote and office satellite. Next application for space and aerospace. Now these application of solar tracking systems are residential application. Residential application solar tracking system are used in household purpose. Now next is commercial and office. Commercial implementation of solar tracking system are used in commercial for building, office building and shopping center. Next solar tracking system are used in agriculture. Now for agriculture, solar tracking are used in agriculture irrigation. Now next is industrial sector and solar farm. Now this is solar lab. Thank you for attention and suggestion and comments.
First of all, let's appreciate your smart presentation and good slides, good animations, and for the future encouragement, let's have some suggestion from Jitendra Kumar Manandaswar.
Where are you going to use the solar tracking system in near future as an application?
Which may be the best approach initially. हामीले सुरुमा अब यसलाई चाहिँ के भने रियल फिल्डमा यदि एप्लाई गर्ने भए कुन सेक्टर चाहिँ सबभन्दा पहिलो हाल्ला?
मोस्टली त हिली रिजन भइहाल्यो पहिला। त्यहाँ इलेक्ट्रिसिटीको पहुँच छैन, त्यहाँ सोलर ट्र्याकिङ सिस्टम त्यसमा पनि पहाड छ, कुनै बेला घाम छेकिन्छ, कुनै बेला छेकिँदैन, तर सोलर ट्र्याकिङ सिस्टम युज गरेपछि अटोमेटिकली सोलर डिटेक्ट गरेर अटोमेटिक सोलर रोटेट हुन्छ त्यही अनुसार। अनि सनलाइट यदि इस्टमा छ भने सोलर इस्टतिर फर्किन्छ, वेस्टतिर छ भने वेस्टतिर फर्किन्छ, नर्थतिर साउथतिर, त्यस्तै गरेर त्यो म्याक्सिमम इफिसियन्सी आउटपुट टु द म्याक्सिमम इफिसियन्सी गिभन बाई द सोलर ट्र्याकिङ सिस्टम टु द ब्याट्री एन्ड एनर्जी स्टोर वी क्यान युज इट फर in remote area for internet, household purpose, and many more. Also we can use it for solar, just the solar farm. We use solar farm for just, we have to operate an airport. Large solar farm, large solar area should be included to produce the huge amount of energy. To run the airport, we have to store the huge amount of energy, which is only possible through the solar farm in the remote area. And next application is in factory.
ओके अदर सरले एउटा चाहिँ प्राइमेरी चाहिँ के हुनसक्छ भन्ने कुरामा सर भाइले एन्सर दिनुभयो। सर ठिक छ अहिले
सबैभन्दा त पानी नै होला नि हैन र, त्यही बेलामा त भनिहाल्यो नि एयरपोर्टै त के चलाउन र अहिले तपाईलाई चाहिने पानी हो खेती गर्न, त्यही वाटर पम्प चाहिँ लिफ्ट गरेर त्यही नै सबभन्दा चाहिँ सिँचाइ गर्नको लागि नै सबैभन्दा उपयुक्त होला नि हैन र।
नेपाल झन् पहाडै ठाउँ छ पुरै।
त्यही त थ्याङ्क यू भेरी मच जितेन्द्र सरले यति राम्रो सजेसन दिनुभयो। भाइहरूको चाहिँ के त भन्दाखेरि एप्लिकेसन चाहिँ रियल अहिले तुरुन्तै युज हुन सक्ने ठाउँ के छ भन्ने कुरामा सरले औँल्याइदिनु भयो। हाम्रो प्रेजेन्टेसनलाई विटनेस गरिदिनु भएकोमा जितेन्द्र सरलाई हामी धेरै थ्याङ्क यू थ्याङ्क यू। अडियन्समा यसो फोकस गरेर हामी लास्ट थ्याङ्क यू भेरी मच।